So we're going to talk about when we change things in our probability model, how that's going to affect our expected value or mean and our standard deviation. So as a warm-up, if we find the expected value and standard deviation like we learned before, what we're going to find is that the expected value is 74. If we do each x times each p of x and add them all together, our variance ends up being 84, and then if we square root that, our standard deviation is 9.165. So the question is, what happens when we start changing stuff around? So for example, if I take each of those x's and I add 50 to them, what do we think is going to happen to our expected value and our standard deviation? Well, what ends up happening is that our expected value is going to increase by 50, as we might expect. Standard deviation, however, is not going to change. And if you can think of that as, if we were to use that standard deviation or variance formula, we're going to be doing 110 minus 124 squared times 0.2, and that'll end up the same as if I do 60 minus 74 squared times 0.2. So that's why it ends up being the same as far as the formula. Okay, so similarly, if I take each of those x's and I multiply by 3, what do we think is going to happen? Well, the expected value gets multiplied by 3, just like we would expect. The standard deviation also gets multiplied by 3. So this is similar to our rules that we learned before about how scaling and shifting affects the measures of center, or the mean in this case, and the measures of spread, or the standard deviation. So we're going to look at some actual rules. So if you're looking at your paper, you can look at that. So the expected value when we add or subtract a constant to each value of x in the probability model will be e of x plus or minus c. So if we add or subtract a number, the expected value just gets added or subtracted that same number. The variance and standard deviation when I'm add or subtracting a constant is not going to change. So the variance and the standard deviation, if all we're doing is add or subtracting a constant, the variance and standard deviation will stay the same. Okay. For our constant rule or scaling, if we multiply by a constant, the expected value also gets multiplied by that constant. The variance will get multiplied by that constant squared, because remember, variance is standard deviation squared. Standard deviation just gets multiplied by that constant. So we saw that as an example in the warm-up. Okay, so moving on to a little bit something different. If we have two random variables or two different probability models that we were dealing with, for the expected value, if I'm adding or subtracting those two models together, the expected value is just going to be the two different expected values added or subtracted together. Just like we would expect. For the standard deviation, however, it's a little bit more tricky. For that, we kind of have to take a step back and look at the variance. One thing that's important about this is if x and y are not independent, then we can't actually find the variance and standard deviation. So that'll be important later. But for now, for my variance of x plus or minus y, when I'm adding those two things together or subtracting, will be variance of x plus variance of y. It will always be a plus. Variance and standard deviation always increases, even if we're subtracting two variables. And we'll look a little bit more at that later about why. So standard deviation, one way to find it would be to find the variance first and then take the square root of it, and that works, and that's perfect. But a lot of times we're not given the variances, so it's just a little bit quicker to go straight to standard deviation. So the formula for that is square root of standard deviation of x squared plus standard deviation of y squared. Again, it's always a plus, even if it's minus over here. Okay? So those are the rules. And now we will look at the examples. I am going to move forward, though, and show you real quick. I have to go forward in the slides. Come back to this. Okay, so why do we always add variances? Well, we're going to talk about poodles and German Shepherds. So a German Shepherd weighs anywhere from 75 to 95 pounds. So we can think of that as 85, give or take 10 pounds. So 10 in this case representing our variance, so to speak. Poodles weigh between 40 and 50, so 45 plus or minus 5 pounds. Okay, so if we were to add two random dogs' weights together, a German Shepherd and a poodle, Okay, the lowest value we could possibly get if we add those two things together would be the two lowest values. 75 plus 40 is 115. The biggest value I could get would be if both of the dogs weigh as much as they possibly could. So 95 plus 50 is 145. The middle of that would be 130, give or take 15 pounds. So look at our variances. 10 plus 5 is 15. That makes sense because we were adding the two weights together. So we feel like that makes sense. But when we look at the subtracting, what we'll see is that it may not do what you would think it would do. So if we're subtracting those two dogs' weights, the lowest possible value I could get if I'm subtracting the two weights. Think about if the German Shepherd weighed 75, the lowest it could possibly weigh, but the Poodle weighed 50, the highest it could possibly weigh. Well, 75 minus 50 is 25. So the smallest number I could get by subtracting the weights is 25. Similarly, the biggest number I could possibly get by subtracting their weights, well, what if the German Shepherd weighs 95, but the Poodle only weighs 40? So 95 minus 40 is 55. So that weight range that I get is anywhere from 25 to 55 is the difference, which if we look at it is 40 plus or minus 15 pounds. So even though I subtracted the weights, my variance still ended up being 10 plus 5 is 15. So when you are adding or subtracting two different things, you're still going to have an increased variance no matter what. So that is why.